Right, hello GH101. We're going to stick with doing base conversions. We've talked about binary and octal and decimal, and there's one more that's important, hexadecimal. So base 2 was ones and zeros. Base 8 we started with was digits 0 to 7. Base 16 uses digits 0 to 9 and A to F, which is called hexadecimal. And we will see a good reason for hexadecimal. Actually, let's look at that right away to get you motivated. So one reason, color codes. All right, let's look at web color codes. Okay, so in the web, you can specify colors in a number of different ways in the code. So you can say black, red, and so on. Or you can give hexadecimal color codes or RGB color codes. So let's see. This is something that works right now, but who knows when you're actually watching this. Okay, so if I click around here, then whatever color I click on, this is the color, and this is saying the color code for that is this, right? This thing here. So let's slide this all the way up to red. So the color code in the web, in the HTML code for this color, which is just red, would be 255.00. Let me make a note. This is in our data. We're going to say image color codes. So one way to specify colors is you specify a red value, which is 0 to 255. 255 because of binary. I'll say something about that in just a second. Green value is 0 to 255, and the blue value is 0 to 255. So every pixel on my screen in your pictures or whatever, it's made out of a red part, a green, and a blue. So the color red is 255.00. So that's maximum red and no green or blue. Green is no red, maximal green, no blue. Okay, what about white? So white is all of the colors. If we're trying to make a white pixel, we're either going to turn all the colors on or all the colors off. Which is it? All the colors on. Okay, so max red, green, and blue is white. Black is no color. All right. How about what happens? So what color do you get if you mix red and green? So if we have 255, 255, 0, what color do you get? Red and green. This link will work for now. We'll save that. Okay, so what if we do, is it going to let us? This one doesn't. We can sort of get in there. Red and green are supposed to make orange or yellow. There's yellow. Okay. So red, green, 255, 255 is yellow. So in your, in your HTML file, it will say the color is supposed to be something like that. I'll note why 255, because we're going to use 1 byte to store the value, the red value and also the green value. And 1 byte is 8 bits. Okay, so the maximum value is all bits to be 1. Right, so there's 8 bits, they're all 1. All right, so if we're having 8 bits and we want to have the biggest number that we can have with 8 bits, you set them all to 1s. It's binary. It's either 1 or 0. And what is the decimal value for this? It happens to be 255. All right, so that's why 0 to 255 is because they're each 1 byte. And the biggest number you can store in 1 byte is 255. Okay, now I was not looking at, so these are just decimal numbers. It's a little bit shorter to type this, which is hexadecimal. So this is a 2 hexadecimal digits for red, 2 hexadecimal digits for green, and 2 hexadecimal digits for blue. And that doesn't necessarily make sense to you yet, but it's a reason. In hex 255, let's see, 255 decimal equals FF hex, and we'll see why in a second. So in hex we have red goes from 00 to FF, green from 00 to FF, and blue from 00 to FF. So that we have red is FF00. So we're going to put the zeros in if there's nothing there. So this means all red, no green, no blue, and white would be FF, FF, FF. So that's maximum color on each. If you just trust me that FF is the maximum, that means 255. Okay, so there was some motivation, and good. Now let's look at base 16. We'll go over to our slides. We'll go over to our slides. Base 16 hexadecimal. All right, so now instead of talking about digits can be, base 10 is there's 10 different digits. Base 2, there are 2 different digits. Base 8, there are 8 different digits. So now we're going to do 16 different digits. And these different digits are the regular ones. Okay, 0 up to 9, but now I don't want to use this as a digit. That would not be good because 1 and 0 are digits I'm already using. So instead I go to letters, A, B, C, D, E, F. So those are my 16 digits. And the values, A means, so A in hex means the value 10. B is 11, C is 12, D is 13, E is 14, and F is 15. Okay, so in hexadecimal, when you see C, you think what? 12. All right, let's try an example. Let's say I have the number, we'll start with FF. All right, so what does this mean? We have these digits, 16 different digits, and we're also going to be doing powers of 16. When we were back with decimal, we had powers of 10, 0. The 0 power of 10 is the ones digit, and then we have the tens, and then we have the 10 squareds. In base 8, we had powers of 8 in terms of what the numbers mean. In binary, we have powers of 2. Okay, we're going to do the same type of thing, but now we're going to do base 16. So we have f times some power of 16 plus f times some power of the next power of 16. Okay, so this is the ones digit, so this is f times 16 plus f times 1. So we have the ones digit, and then we have the 16s digit, because we're doing powers of 16. And when we see f, we think 15. So 15 times 16 plus 15 times 1. And what is that? If you don't believe me, you'll believe Google. It's 255. All right, so that's the 255 is the max color, and FF is that as well. Let's go with another one. Let's go with, let's say we have the number F072, or A, all right? So we're going to have f times some power of 16, and let's see, this is going to be the 0 power, the ones digit. This is the 16s digit. This is the 16 squared digit, and this is the 16 cubed. So the 16 squared digit is 0. Okay, now I'll put in the 7's fine. 7 just means 7, but for f I have to put 15. Let's do this. For the A, what does that mean? That means 10. Okay, so now this is not something that I can type into Google, so I'll put in a form that I can copy it over. 10 times 16 times 16 times 16 plus 0 times 16 times 16 plus 7 times 16 plus 10. $61,562. Is that what it was? 61,562 in decimal. Okay, so from base 16, there we go. What if I give you a number? What if I give you a number like 101? Let's do this. We'll make a new slide. Base is fun. All right, so what if I give you a number like this? Okay, what kind of number is that? Is that a binary number, or a hex number, or an octal number, or whatever? So what base is this number? Could be any. We could think of it as any of them. So we need to specify whether we mean this to be 10,110, or do we mean the binary number? So let's see what we would get for all of those. So if we think of it as binary, if we think of it as octal, if we think of it as decimal, and if we think of it as hexadecimal. Okay, decimal, we're just going to say this is the same. All right, so that's 10,110. All right, for the rest of these, we're going to have 1 times something, plus 0 times something, plus 1 times something, plus 1 times something, plus 0 times something. All right, in binary, we're doing powers of 2. Okay. All right, what does that equal? We've got a 16, we've got a 4, and we've got a 2. So that's 22 decimal. All right, question. When we do the octal version, is this going to be bigger or smaller than 22? And you should do it. Go ahead and do the octal version and see what you get. Pause it and do it. Did you pause it and do it? So for octal, we're going to put in 8 instead of 2. Okay, so in octal, this 1 here doesn't mean times 16, it means times 8 to the 4th. All right, so this is going to be 8 times 8 times 8 times 8 plus 8 times 8 times 8 plus, this was, sorry, this was a 0. All right, so we've got a power of 4, a power of 2, and a power of 1. So whatever that equals. $4,168. All right, now what about hexadecimal? What do we do differently, and what do you get? Pause the video and do it. All right, so now I'm going to do 16s instead of 8s. So we've got a power of 4 of 16, and a power of 2 of 16, and a power of 1. Is that going to be bigger or smaller than 10,110? $65,808. Okay, so converting from decimal to hexadecimal, or sorry, from hexadecimal to decimal, that's what we do. And we'll do just one other thing, which is super useful with hex. And it's important enough that I will put it over here. So hexadecimal, let's see, we have the colors there. Hexadecimal is base 16, uses zeros, called hexadecimal, and we'll say powers of 16 are in there. One reason is color codes. Another reason, 1 hexadecimal digit is 4 binary bits. So let's look back at our examples and let's look at another example to see how that works. So let's look at example 7 we'll say 90A2 hex. All right. So my claim is that if I want to write the binary for this number, then I can just do the binary for each digit. So what's the binary for 9? Well, 9 is 1001. So is that true? So this is the 1's digit, the 2's digit, the 4's, and the 8's digit. So 8 plus 1, that's 9. What's the binary for 0? Just 0, but the rule is they have to write 4 bits for it. Okay, what about A? What is A? A is 10, which is 8 plus 2. So I have the 8th bit and the 2's bit. That's 10. And then I want to write 2. 2 in binary is 10, but I need to make it 4 bits, so I put leading zeros, because leading zeros doesn't change the number. So my claim is that this is the same as this. So let's go to a binary hex calculator. Okay, I wanted to put in 90A2. And look what I got. I got a 1001, and then I got 4 zeros, and then I got a 1010, and then I got a 0012. So these are both equal to whatever it said the decimal is. You can work it out. 37026. Okay, so if you take the hexadecimal number and you put 4 bits for each of the digits, then that is the correct binary. And you can also go the other way. So if I have a number, if this is my binary, if I group it into 4s, okay, so here I have it grouped into 4s and put a leading zeros there to make it 4 bits. So this in hex, I just have to write down, this is a 2 in hex. This is 8 plus 2 is 10, that's A. Another one of those. This is 8 plus 4 plus 2, and not plus 1. 8 plus 4 plus 2 is 14, that's E. 2AAE, if I put that in as hex, do I get, so 00010, then I have the 1010, then I have the 1010 again, and that. We'll save this. All right, and that's what we had. All right, so over here, the rule is it goes both ways. So 1 hex digit is 4 binary bits, and when doing this conversion, each hex digit, let's see, put in leading zeros if needed to have 4 bits for each hex digit. Okay, and there's a practice. Okay, so this is really cool. If we look at hex numbers, we can think of them as bits. I'm going to give you just a little teaser. So let's look at just as a little teaser, I'm going to download a Let's say I want to download a PDF about how to swim. I don't know. All right, I'm going to download this file. So what was that called? So now I'm going to show you something that you don't need to know how to do right now. Where did it save it? Let's try this again. I want to look at, all right. So this is a PDF file. I'm trying to look at it in my text editor, and it's showing all these slash 250s because it's not a text file. It doesn't make sense to look at it in the text editor, but my text editor has a hex viewing mode that'll show me the actual bits. So it starts with %PDF. This is what it is as text, and there's parts of here that doesn't make sense as a text. But what I want to look at over here, so this right here, this tells me, so in Hex, if I just took the bits off the computer that this PDF is, every file in the end is some kind of bits, and it's just how the computer understands those bits. So the first 8 bits of the PDF this is Hex 25. So if I wanted to do my, let's move this up so I have a little more room. So 25 hex is what? 2 is 10, but I have to make it 4 bits. 5 is 101, but I have to make it 4 bits. So that says that on the computer, wherever this is stored, the first 8 bits of that file is this. And if I want to figure out what any of the bits are in the file, I can look at the hex for it, and it's just kind of convenient because each hex digit is exactly 4 bits. Pretty cool. All right. That's the end of hexadecimal. So at this point, you should be able to, let's make notes here. So you should be able to convert binary octal hex to decimal and convert decimal to binary. Right. The end.